In 2004, a scientist pulled a frozen body from Himalayan ice. At first, her team thought it was an ancient traveler. Then the DNA results came back. The closest genetic match wasn't from the Himalayas. It wasn't even from the same continent of origin. The results were so far outside anything expected that 4 universities quietly reran the entire analysis. 3 separate times, different labs, different equipment. The answer never changed. The body belonged to a population that, according to every model scientists had spent decades constructing, should never have existed at that altitude, at that location, at that point in human history. And the deeper they looked, the worse it got. Hi, my name is James. This is Altimeter, the channel that climbs higher to find what history left behind. The Woman on the Ridge. Dr. Sarah Marsh had spent most of her career watching glaciers die. That is not a poetic way of putting it. That is the clinical reality of what a glaciologist does in the 21st century. You return to the same coordinates. You measure. You record how much less ice is there than the year before. And you do it again. She had been doing this for 9 years by 2004. She once described it in an interview as bearing witness in slow motion. Beautiful, she said, and quietly devastating. She was not looking for anything unusual that morning. The survey ridge was familiar. The equipment was routine. The weather was clear, one of perhaps 30 clear days a year at that elevation. She had a standard checklist, a team of 3, and a flight home in 6 days. Then the melt gave something back. A hand, wrapped in a remnant of woven fabric, then a shoulder, then preserved with a completeness that stopped her team from speaking entirely a face. She later described standing at the edge of the find and feeling 2 things at the same moment. The first was awe. The second was dread. Because even before the analysis began, even standing on that ridge with wind cutting across the ice, she understood that what she was looking at was not a recent tragedy. It was ancient. And ancient, at that altitude, in those conditions, meant the story behind it was one that no one had anticipated. She was right. She just had no idea yet how badly right she was. What the ice actually does. Before we go further, I need you to understand one thing, because it changes everything that follows. Glaciers are not simply frozen water. They are archives. When organic material becomes entombed in glacial ice under the right conditions, the process of decay does not slow down. It stops entirely. The cold eliminates the bacterial activity that drives decomposition. The pressure seals the environment. What you get in the cases where conditions hold is preservation that most people find genuinely hard to believe until they see the evidence. We know it works because the ice has already shown us. In 1991, hikers in the Alps found Ötzi, a man dead for 5,300 years, preserved so completely that scientists could read his last meal and his stomach contents, identify the parasites in his gut, and sequence his entire genome. In 2013, a woolly mammoth came out of Siberian permafrost with liquid blood still present in the tissue. Liquid blood. After 28,000 years, the Himalayas hold more frozen water than anywhere on Earth outside the polar regions. The conditions in the highest glaciers are in some locations almost precisely designed for this kind of preservation. So when the body came out of the ice in 2004, the preservation scientists didn't say it was impossible. They said it was exactly what a glacier does. What they said next quietly, after the first round of dating came back, was that it was old. Not decades, not centuries. The kind of old that doesn't just raise questions. It erases assumptions. The story that assembled itself. The Himalayas have been inhabited for thousands of years. That's established, documented, not contested. Trade routes through mountain passes existed for millennia. Pilgrims, merchants, soldiers, and shepherds have crossed extreme terrain in this region for as long as civilization has existed in Asia. When the body was found, the framework was waiting. Ancient traveler, known era, known region. A death in the mountains, comprehensible, sad, fully expected within the existing picture of human movement through the corridor. The initial radiocarbon dating returned a result that seemed to confirm it approximately 1,000 800 years before the present. The textiles matched broadly. The tools were recognized. The burial position fit within cultural practices the archaeologists knew. The story assembled itself quickly. Too quickly, as it turned out. Because when the genetic analysis came back, it didn't just complicate the timeline. It didn't just add a wrinkle. It broke the story apart completely. The database wasn't failing. History was. The result that shouldn't exist. Here is what ancient DNA analysis actually does. When scientists extract genetic material from old remains and sequence it, they compare the profile against a reference database, thousands of modern and ancient genomes from across the world. This comparison tells you where a person's ancestors came from, which migration waves they belong to, where they fit in the map of human prehistory. Think of it like a family tree that reaches back 50,000 years. The body's DNA didn't fit on that tree. Fragments of the profile showed partial connections to Central Asia. Other fragments overlapped with populations from the eastern edge of what is now Iran. But the specific combination, the way those pieces were assembled, had never been seen before. Not in any modern population anywhere on Earth. Not in any ancient individual ever sequenced. It was like finding a passport from a country that no one knew had existed. The lead researcher described reviewing the first results as opening a file in the wrong program. The data was real. The sequencing had worked. But what it was showing had no home in any existing record. They ran it again. Different laboratory, same samples, same result. They expanded the comparison to every ancient genome in the published scientific literature. Hundreds of individuals spanning 45,000 years of Eurasian prehistory. And that is when they found something. Not a perfect match, a partial one. The closest genetic relatives the database could identify were people from a population that had lived thousands of miles to the west in a region that is now modern Iran and the southern Caucasus. Those individuals had lived not 1,800 years ago. Approximately 5,000 years ago. 5,000 years ago predates the first cities of the Indus Valley civilization. It predates Stonehenge. It predates the earliest written record of any human civilization by more than 1,000 years. And it predates every accepted model of high-altitude human habitation in the Himalayas by an enormous, uncomfortable margin. The team had three options. The equipment was wrong, the samples were contaminated, or something had been living in those mountains that the entire record of human history had missed. They had already ruled out the first two, which left the third. The detail the DNA couldn't explain. Here is where it got worse. The body showed no signs of altitude sickness. That sounds like a small detail. It is not. The physiological adaptations that allow people to survive above 4,000 meters, reduced oxygen uptake, altered hemoglobin production, cardiovascular changes that took thousands of years of natural selection to develop are trackable in the genome. Scientists can see them. They are specific. They are measurable. The body from the ice did not carry these markers, not fully, not in the form found in populations that had spent millennia at elevation. Which means, whoever this person was, they were not from a high-altitude, adapted lineage. They had come from lower ground, from somewhere far away, from a direction the genetics pointed thousands of miles west. And yet, no pulmonary trauma, no skeletal evidence of oxygen deprivation, no markers of acute mountain sickness. This person had acclimatized, fully, over time. This was not a traveler passing through a dangerous crossing. This was someone who had arrived at altitude and stayed, possibly for years, possibly for generations. And the moment that possibility entered the room, the entire framework of the investigation shifted. The question was no longer, how did this person get here? The question became, how long had their people been here? The theories that didn't hold. The team considered every explanation, systematically, one by one. Migration wave. The Bronze Age saw massive population movements. The expansion of steppe peoples pushed west into Europe and east into Central Asia with a speed that stunned archaeologists when ancient DNA first revealed it. Could a related wave have pushed further south all the way to the Himalayan approaches? The profile wasn't steppe. It was older, by at least 1,000 years. The migration theory needed a source population that didn't appear anywhere in the record. Dead end. Long-distance trade. The ancient world was more connected than we used to believe. High-value goods, lapis, lazuli, copper, tin, moved across extraordinary distances through chains of intermediaries. Could this have been a Western trader following a route no document records? Think about what that would require. A person from modern Iran, walking east for months, crossing some of the most extreme terrain on Earth, reaching altitudes that kill unadapted climbers within days, and surviving long enough to acclimatize fully. Possible in theory, impossible in the body in front of them. Dead end. Local misidentification. Perhaps the database was incomplete. Perhaps there was a known population with this genetic signature that simply hadn't been sampled yet. 4 universities. 3 reruns. 8 years of additional sampling across Central and South Asian populations. The signature remained unmatched. Dead end. That left the third option. The one no one in that room wanted to say out loud. Because saying it out loud meant accepting that somewhere in the high Himalayas, at a time that predated every civilization we have a name for, there had been a people, and we had simply never known they were there. The evidence that had been there all along. Here is the part that I still find difficult to process. In the years following the initial discovery, researchers began pulling at a thread that had been sitting in the scientific literature for a long time. Unexamined. Not because no one had found it, because no one had thought it was worth taking seriously. Across multiple high-altitude sites in the wider region, locations above 4,000 meters, that archaeologists had assessed as too extreme for sustained habitation before the last 2,000 years. There were traces, stone tools, fire sites, animal bone with the processing marks of deliberate butchery rather than predator kills. These finds had been documented across decades of survey work. In most cases, they had been dated once, found to be anomalously old, and quietly reclassified as uncertain. The uncertainty wasn't scientific. It was conceptual. The dates didn't fit the model, so the dates were treated as probably wrong, filed, set aside, left to sit in archive folders while the research moved on to questions that had acceptable answers. When teams began re-examining these sites with updated methodology, the dates held. Most clustered between 3,000 and 5,000 years ago, the same period the body's genetics pointed toward, the same altitude range, the same geographic corridor, the same impossible era. This was no longer one anomaly. It was a pattern. A pattern pointing at people who had lived at extreme altitude, during a period we have no name for, in a place we had decided in advance was uninhabitable. We didn't miss them, because no one was looking. We missed them because we had already decided what we were allowed to find. The melting clock. The glaciers are melting. Not slowly, not at a rate that gives us time. The Hindu Kush Himalayan region has lost an estimated 65% of its glacier volume in the past century. The pace is accelerating. Under current trajectories, models project that 2/3 of what remains could be gone by 2100. That ice is an archive. And the archive is being destroyed in real time. The body found in 2004 survived because it emerged in the right window, cold enough still, ice intact enough, DNA degraded but recoverable, fabric preserved, face readable. If it had surfaced 20 years later, in zones the melt is now reaching, the outcome might have been completely different. We got lucky. Once. Researchers working high-altitude melt zones have since documented additional anomalous finds, organic material, fragmentary remains, artifacts that carry the same temporal and genetic disruption. Most remain unannounced. The work is underfunded, logistically extreme, and scientifically controversial in ways that make institutional support difficult. Whatever story is still frozen up there is coming out now. On the glacier's timeline, not ours. The archive is opening. Whether anyone is ready to receive it is a different question entirely. The only question that matters. The headline version of this story is already remarkable. A body. Impossible genetics. A population history doesn't record. A chapter of human prehistory that may have been there the whole time, frozen in ice, waiting for a melt that finally came too late for anyone to be ready. But that is not the part I keep returning to. The Himalayas are among the most studied mountain systems on Earth, more than a century of sustained scientific attention, and the evidence was there the entire time. In field notes, in anomalous dates that got filed as uncertain, in samples that didn't fit and were set aside instead of followed. We didn't miss this population because the evidence wasn't there. We missed them because the framework told us they couldn't have existed. And when the evidence pushed against that boundary, the system's response was not curiosity. It was silence. That is not a failure of individuals. It is a failure of certainty. The certainty that we already know the shape of human history well enough to dismiss what doesn't fit. The Himalayas were supposed to be an answered question. They were not. And if they were not, then what other questions are sitting in other archives right now, filed under uncertain, waiting for someone to look again? The body found in 2004 is currently housed in a climate-controlled research facility. 11 teams across 4 countries have studied it. The genetic analysis has been published, disputed, refined, and published again. The consensus, built slowly and reluctantly, is that the findings are real. The glaciers are still melting. Whatever else is preserved up there, and the evidence increasingly suggests there is something, it is moving toward the surface right now. We found one person. We may have found them only seconds before the ice let go forever. For thousands of years, the mountains kept this story buried beneath ice that never moved. We may have discovered it only moments before it disappeared. My name is James. This is Altimeter. The archive is opening, and the clock is already running.